Section 9.3, Solving Quadratic Equations. The objective of this section? To solve quadratic equations by graphing and using square roots. Lesson vocabulary: quadratic equation, standard form of a quadratic equation, root of an equation, zero of a function. An essential understanding: quadratic equations can be solved by a variety of methods, including graphing and finding square roots. The diagram shows a plan for your new garden. You want to use only 1.5 cubic yards of topsoil and plan to spread a layer 4 inches deep. What are the dimensions of the largest garden you can build? And how do you know? Well, we know the volume of the topsoil will equal length times width times depth. That's because it's really just a rectangular prism. What is an equation for the garden topsoil volume using the same units for all dimensions? Explain. Notice we have the dimensions labeled here on this rectangular prism that represents our topsoil. 4 inches deep, 2x yards long, and x yards wide. We know that volume equals length times width times depth. Converting 4 inches into 1/9 yard, we get consistent units throughout our problem, and then substituting these things into the volume formula and simplifying, we find that the volume equals 2/9 x squared cubic yards. The situation in the solve it can be modeled by a quadratic equation. For your notes, a key concept: standard form of a quadratic equation. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, our leading coefficient, does not equal 0. This form is called the standard form of a quadratic equation. One way to solve a quadratic equation in standard form is to graph the related quadratic function y equals ax squared plus bx plus c. The solutions of the equation are the x-intercepts of the related function. Take a look below. What we see graphed is y equals x squared minus 4. And so considering y to be equal to 0, recall those would provide our x-intercepts, we can solve this new equation by considering the graph and finding the x-intercepts. Well, note we have two x-intercepts. Our parabola crosses the x-axis in two places, one of those places being -2 and the other being +2. So our solutions are x equals both positive and -2. We've seen it graphically, but let's confirm with our equation. Substitute in -2 for x. -2 squared is 4. 4 minus 4 is 0. Substitute +2 for x to check that solution. 2 squared, also 4, and 4 minus 4 is, last time I checked, it's still 0. So using this graphing method, it's important to note that a quadratic equation can have 2, 1, or no real number solutions. Consider parabolas. It's possible to construct a parabola that crosses the x-axis twice. It's also possible to construct a parabola that only intersects the x-axis in exactly one spot, and it's possible to have a parabola that doesn't intersect the x-axis at all. These graphs represent quadratic equations that have 2 solutions, 1 solution, or no real solutions, respectively. The solutions of a quadratic equation and the x-intercepts of the graph of the related function are called the roots of the equation or the zeros of the function. Example problem 1. Solving by graphing. What are the solutions of each equation? Use a graph of the related function. Well, our equation x squared minus 1 equals 0 can be graphed using the related function where y replaces 0, and we have the equation y equals x squared minus 1. Considering that graphed parabola, we find two x-intercepts, those being positive 1 and negative 1. So two solutions to this quadratic equation, negative 1 and positive 1. Part B, x squared equals 0. The related function y equals x squared. Considering the graph of that parabola, we have exactly one x-intercept, so 1, 0 of the function, which we can also call the root of the equation. That would be 0. Note how the x-intercept is right at the origin. One solution, 0. And part C, x squared plus 1 equals 0. The related function y equals x squared plus 1, graphed below. Note this parabola has no x-intercepts, meaning the quadratic equation has no real solutions. And your first of three got it questions. What are the solutions of the equation x squared minus 16 equals 0? Use a graph of the related function. Work carefully and make your selection from the choices below. Question 2 of 3. What are the solutions of the equation 3x squared plus 6 equals 0? Use a graph of the related function. Work carefully and make your selection from the choices below. And got it, question 3 of 3. What are the solutions of the equation x squared minus 25 equals negative 25? Use a graph of the related function. Work carefully and make your selection from the choices below.